Hello viewers, good morning and welcome to my YouTube channel Beauty Kenny. Briefly on the board, I'll be taking you on some JAMB likely questions. That's questions you can see in your forthcoming JAMB. Let's proceed to the board. The first question says, 8 grams of CH4 occupies 11.2 at STP. What volume would 22 grams of CH3, CH2, CH3 occupy under the same conditions? Now, how do we solve this question? The first thing is this. I'll divide the board into two so we can. Now, it says 8 grams of what? CH4 occupies 11.2 at STP. There are some points we need to consider. STP, okay? And also this CH4, we need to know what it means. And this other points too. So CH4 is what? Methane. Under the when you talk about organic chemistry, okay, CH4 is methane, and we have CH3, CH2, CH3. Now, what is this compound? What we're going to do is, first of all, you're going to count how many carbons do we have. We have 1, 2, 3. So we have 3 carbons, okay? And how many hydrogen do we have here? 3 plus 2 plus 3 is what? 8. So CH8. So we have CH3H8, and this is what? Propane. This is propane. Okay. And also, we are going to look at the word STP. STP. What does STP mean? It means what? Standard. It means standard temperature. It means standard temperature and pressure. Okay. Now, if we can understand this point, we can solve this question. It said 8 grams of CH4 occupies 11.2 at STP. What volume would 22 grams of CH3, CH2, CH3 occupy under the same conditions? Now, what does it mean? For us to solve this question, we need to understand how gases operate under STP, that's under standard temperature and pressure. Note this. Note that 1 mole of gas operates 1 mole of gas operates at what? 22.4 dm cube. Please take note. That's at STP. Okay, at STP. That's at STP. 1 mole of gas operates what? At 22.4 dm cube. This is what we should note first, so we can solve the question. Now the question says 8 grams of what? CH4 occupies 11.2 at STP. Now what we are asked to look for is what volume would 22 grams of this? So I don't want to waste your time. Let's get straight to the point, because of, when you're solving your questions, there's no time. Okay, so the question said what volume. We're looking for volume of propane, that's C3H8. okay. 1 mole of gas operates at what? 22.4 dm cube at STP. That's at STP. 1 mole of gas operates at 22.4 dm cube. So now we're asked to look for what? The volume of propane, that's C3H8. Now we're going to look at we are given that the grams of propane is what? 22 grams. So that's to say what? The mass of propane, we don't know. The mass of propane is what? Given us 22 grams. Okay. Now we don't know the molar mass. We don't know the molar mass of propane. Now, how do we solve the molar mass of propane? Since we know the chemical combination of propane, that's C3H8. It's already given that carbon is equals to what? 12, and hydrogen is what? Equals to what? 1. That's what? The atomic number, okay? Atomic mass, sorry. C12 and what? H1. So how do we solve? We know that carbon is having what? A subscript of 3 here. So what do we do? So it becomes what? 3 into 12, okay? Plus 1 into 8. One, expand the bracket. What do we have? 3 times 12 is what? 3 times 12. 12 times 3. That's 36. Plus what? 1 times 8 is what? Equals to 8. So 36 plus 8 will give us what? 44. Okay? So this becomes what? This is grams per mole. Okay? So this becomes the molar mass of propane. So okay, so let's proceed. Okay. So the molar mass of propane is equal to what? 44 grams per mole. So we are asked now, how do we get the mole of, so we can calculate the volume, the mole of propane. So for us to do that, we have to calculate the mole of propane. How do we calculate the moles of propane? The volume, we need to calculate the moles of what? Propane. And that's going to be what? Moles of propane is equal to mass over what? Molar mass. That's number of moles. We're looking at number of moles. We're looking at number of moles of what? Propane. Is equal to mass over what? Molar mass. So now from this solving, what is our mass? The mass of propane is what? 22. Where is it? The mass of propane is what? 22 grams. Okay. So we have 22 over what's the molar mass of propane? That's 44. Okay. Now when we divide this, I don't have calculator. This is intentional. I did this intentionally so that in case you are attempting a question and there's no calculator for you, this is what you're going to do. We're going to use what? Long division method. Let me clean the board so we can flow. Long division method. Okay. Okay, so when we use long division method, we have, see how it goes. 44 will be what? The divisor. Y22 will be what? The dividend. So 44 into 22, what? It will not go. So we have what? 0 points. Put your decimal point. We add 0 here. 44 into what? 220. What will 44 multiply to give us 220 or a number close to 220? What do we do? Let's see if we can use them. I think 5 times 4 is 20. Let's see. 44 times 5. 5 times 4 is what? 20. The other 0 carry 2. 5 times 4 is 20. 20 plus 2 is what? 22. So 5 will go. So 5 times 44 is what? 220. You subtract, you have 0, 0. So it becomes what? 0.5. So the number of moles is equal to what? 0.5. And volume of propane will be what? Is equal to the number of moles now, 0.5 times what? 22.4. Please take note, I said something that at STP, that's at standard temperature pressure, 1 mole of gas operates at what? 22.4 dm cube. I know the question say for under the same condition. So now since we've gotten our number of moles, we're going to multiply it at what? STP, that's 22.4. So when we multiply this 0.5 times 22.4, it's going to give us 0 times 5 times 22.4 will give us what? 11.20. Okay, so this becomes the volume of propane at STP under the same condition. So let's look at the options given to us. You have 3.7 dm cube. You have 11.2 dm cube C. We have 22.4 dm cube. We have T 33 dm cube. We haven't solved this. The volume of propane now is what? 0.5. That's the number of moles times what? 22.4 at STP. Number of 1 mole of gas operates, okay, at 22.4 under what STP. So we've gotten our answer as what 11.20, and the options given to us from the question says A 3.7 dm cube, B 11.2 dm cube, C 22.4 dm cube, D 33 dm cube. So the answer is what 11.2 dm cube. Now if you want to verify this because of time, maybe when you're solving your, maybe when you're having your personal study time, so what you're going to find, if this 11.2 applies to all the compound mentioned, they mentioned methane there, okay, you use the same process to solve and see if it's the same thing. Now what you're going to do is this: you look for what the mass of methane was given as 8 grams, right? So you take the mass of methane, that's 8 grams. You look for the molar mass of methane, okay? When you look for the molar mass of methane, you now also apply it. When you get the answer, you multiply it by what this STP given to us as at STP, where gas, 1 mole of gas operates. Then you see that the same answer is going to give you what the same answer as 11.20. So the answer here is what 11.2 dm cube. The next question says the best treatment for a student who accidentally poured concentrated tetraoxosulfate 6 acid on its skin in the laboratory is to wash his skin with what? Now this is a practical thing that occurs all the time, even when you're trying to perform your experiment in the lab, okay, trying to perform maybe titration and all that, okay. So such thing can happen. So now what do you do when such a thing happens? Now take note, this acid is concentrated, okay. Now it pours on his skin, and that's to say it will cause what? Damage on his skin. So what do you advise the students use to what? Prevent further damage? A, he said sodium trioxynitrate 5 solution. B, with cold running water. C, sodium hydroxide solution. D, iodine solution. Now take note, the first one, sodium trioxynitrate, will cause more damage to the person, so it's not advisable you use what? Sodium what? Trioxynitrate on the person's skin, okay. Secondly, with cold running water. Now what this water does is what? Help neutralize what? And flushes away the what? Acid on the boy's skin. Now C says what? Sodium hydroxide solution. Now take note, sodium hydroxide is a strong base. Now imagine a base reacting with an acid. What will it hit? What? It will hit what? A neutralization reaction. And take note, during neutralization reaction, okay, acid reacts with base to give what? Salt and water. And this reaction is what? An exothermic reaction. Okay, so in exothermic reaction, heat is what? Produced. So imagine you telling him, okay, please use sodium hydroxide solution in your body. What is it going to do? It's going to what? Cause a neutralization reaction, whereby acid and base will react to give what? Salt and water, and what? Heat is now what? Produced extensively. So that is not what? Advisable for him to use. Iodine solution itself is what? A disinfectant, okay. So when you apply that to the boy's skin, it causes what? More irritation and what? More damage. So the answer to this is what? You cool off with what? Running water. Wash with running water, okay. And the next question says what? An example of polysaccharide is dash. A, dextrose. B, mannose. C, glucose. D, starch. Now what are polysaccharides? Carbohydrates that are made up of long chains of what? Monosaccharides. An example of monosaccharide, that's glucose, okay. So we have options. He said an example of polysaccharide is what? A, dextrose. B, mannose. C, glucose. D, starch. Dextrose is what? A monosaccharide. That's an aspect of glucose. Mannose too is the same thing, what? An aspect of what? Monosaccharides. We have glucose itself. We have starch. So starch is what? An example of polysaccharide because it is complex, okay. That's the answer. So thank you for watching. Please, if you've not subscribed to my channel, please do well to subscribe, as more videos will be, I'll be uploading more videos on biology and chemistry. Thank you for watching. And also, if you have a